Hey everybody, welcome to PC Perspective. I'm Ryan Schrout. Today we have a special event that I initially called All About Power Supplies, or Learn About PSUs with Ryan and Lee. Joining me today is Lee Garbutt, our resident power supply expert, if you will. Some of you who maybe have only started watching or paying attention when we started doing YouTube videos and live streams may not know who Lee is. He's been around, I think, before Jeremy, right about this. Right, well, I meant on the website. He's been around for a long time. He's been part of the team for a very long time. And like we were talking about before we started recording here, was you were actually on the podcast originally with Jeremy and I.
Yes.
But like back in episodes 1, 2, 3, don't go back and listen to those. They're really not that good. Nobody knew what they were really doing at the time. But now 260 episodes later, I think we've got it figured out. But we had not had you on a live stream yet. I'd talked to you for a long time about wanting to do something, and I think we have a really cool lineup of stuff to talk about. And what we're going to talk about today is power supplies. What makes a good one, what you maybe should look for, how they've evolved, different form factors, what some of the key terminology might be that you don't understand, like power factor correction, single rail, multi-rail, all that kind of stuff. We tend to get a lot of questions into the podcast, into This Week in Computer Hardware, into the website in general, about power supplies. What size do I need? And rather than try to do one-off little things, I thought let's bring Lee in, let's do a live stream, let's post this up on YouTube so that we can get as much information out there as possible about power supplies. Yeah. So I guess the most basic question, maybe everybody that's listening understands, is what does a power supply do? What is it necessary for? Maybe how have they evolved?
Okay, that's a fair question.
Yeah.
In the big picture, a PC power supply, you can think of it as a power converter.
Okay.
It takes the AC mains voltage that you get out of the wall, whether it's 120 volt or 240, and converts it to the DC voltages that the computer needs.
Okay.
5 volts, 12 volts, 3.3, your 5 volt standby, minus 12. That's basically what a power supply does. The big ATX power supplies that we're familiar with in desktop computers, everybody's familiar with that, but even laptops have power supplies.
Okay. And is that something that's internal or is it an external power brick?
It can be either way.
Okay.
But somewhere along the line, the power supply has to convert the AC mains current to the DC power. That's the big thing it does.
Okay.
And to make that all happen, one of the main reference is the ATX 12 volt design guide, which was published originally by Intel. And this is the specification that it's used both for the users and the manufacturers that tells them exactly how to build a power supply.
So this manual, version 2.2, we were talking about this earlier this morning. This is the most up-to-date version of it, right?
Yes.
And it's from March 2005.
Right.
And you can see through here, it's all, it's technical documentation about what component vendors need to have, and then what power supply vendors need to supply. And it's kind of interesting that we bring up Intel and all this, because remember with Haswell, we had this issue where they were changing, what was it? Was it a 5 volt restriction or a...
Well, the low power.
The low power.
The ability to operate almost completely shut off.
So is that something that it's not in here necessarily?
No,
and so they were asking for a little bit more support than what is in that particular specification. Interesting. Okay.
The design guide doesn't cover everything, but it hits the highlights, and it basically tells the manufacturer, if they want to get into the business and start making power supplies, what they need to do.
Gotcha.
One of the big things is size. What size does it need to be? That way a case manufacturer can
Physical size. We're talking about the build of the...
Right, like an ATX power supply is typically, this size. It has this dimension, is constant. The depth may vary depending on the output, but so that's a mechanical requirement.
Gotcha.
So a case manufacturer also knows, okay, this is what I need to build so that any standard power supply will fit in my case.
It's interesting because we've seen some variances to that. Antec had, actually we brought an Antec 1000 at one point here that is a, what's that form factor that they call it?
A CFX.
CFX, and it was something that only their cases were built for, and only they made power supplies in that form factor, so no shock that it wasn't a big hit. It was interesting, but it wasn't a big hit, obviously, across the entire industry. So.
Now, when we talk about form factors, there are a number of different form factors.
Right.
The most obvious is the size, and I brought along a couple just to show the difference. Obviously, the ATX, as
Okay.
we're familiar with, but there's also other small form factors for the
like
smaller
this one,
cases.
this is a Silverstone Sfx power supply, 450 watt, and this, as you can tell, you know, compared even to this is an ATX power supply.
Yes.
Here, right? So you can kind of see immediately what that size difference is. This has been for small form factor PCs. Surprisingly, I think a lot of power out of such a small device.
Yeah, that's pretty
450
impressive.
watts,
That's a nice little 450 watt power
and
supply.
fully modular.
Yep.
At the same point. Yeah.
This is a TFX,
Okay.
another shape and size. And then, of course, we have our server styles.
Right.
There's a 1U
Yep.
and a 2U.
So I have built and replaced
You're very familiar with these.
server power supplies many times.
Yep.
You know what's unfortunate about these? Well, actually, even in regular systems, if you look here at these two fans,
Yes.
they get loud.
Yeah.
And a lot of vendors have been building small form factor PCs, even around modern components that use 1U power supplies. And the main drawback for me, at least, is the noise that these fans
Yep.
tend to make.
You can see a 2U is twice the size.
Yep. Now that bigger fan may indicate that it can be quieter. But
Yes.
that's not really the purpose of.
Usually
power
servers
supplies
don't
for
care
servers,
about
right.
noise. That's not a consideration.
Yeah.
And with these little fans, it just sounds like a bunch of hair dryers.
Yeah, it's not great.
No getting around it.
It's not great.
That's
They've
been
tried to tweak it, so.
a big improvement over the years when we've gone to the little 40 millimeter, 80 millimeter fans to the 120, 135, 140.
They can move as much air running
Much slower and
so
be
therefore a lot
much
quieter.
quieter. So,
Now, what's the difference between what's a switching power supply? You always hear people say that, right?
Yes.
Well, this is a PC power switching power supply, and as long as I've been around, I've never seen a not switching.
right, and hopefully you won't.
Okay.
Most
good.
all PC power supplies are what's called a switching mode power supply. And in the big picture, there's two basic types of power supplies. There's a linear power supply and a switching mode. Now, a linear, I've got an example of both. If you'd hand me this is a 240 watt.
So this is that effort to lift it up was not faked. This is what do we weigh it? 20 pounds.
20 pounds.
This is a 20-pound power supply, and we compared it to
This is a 240 watt, a really old switcher,
yeah.
switching mode power supply.
And what do you think the wattage on this one was?
It's 240
This is a
watts.
204. Oh, okay.
It's 12 volts, 24 amps, or 20 amps at 12 volts.
So I don't know if we can show that on here too. So what are we looking at here? What?
Well, this is an example of a.
Oh, over here.
Here, I'll let you hold.
Yeah, I'll hold it. Here we go.
it.
You can point to whatever you want to point to.
The linear power supply just has a few basic components. The main transformer, that's
Okay.
what makes the conversion from your house current, say 120 volts, down to 12 volts.
All right.
Then there's a bridge rectifier or a bank of diodes, which changes the AC to DC
Okay.
along the bottom here on the heatsink. And then there's this blue can is a
That's-
filter capacitor. That's
that's
a
a
large
giant capacitor.
electrolytic capacitor.
33,000 microfarads.
Yep.
Nice.
So the key here is that a linear power supply operates at the line
here, let's
voltage
down.
frequency,
Okay.
which is 60 hertz here in the US or 50 hertz someplace in other parts of the world.
All right.
A switching mode power supply is much different. Obviously, the size and the weight
Yeah.
are a huge difference.
Yeah, you
And
set
the
me up
reason
this
for
morning.
that-
You said, here, this is a
Yep.
240 watt power supply, and you handed me that one. This is a 240 watt power supply, too. Like, you know, when you're not expecting something to weigh as it did, that can be
Yes.
unnerving. So this is the alternate, right? So it doesn't look much smaller, but it is dramatically smaller
Yeah,
in terms
you
of the
could-
components
I
inside.
didn't open this one
Yeah.
up, but yeah, there's not much in there.
Yeah, and you can feel that by its weight,
Yes.
right? I mean, there's nothing as dramatic.
But there is a transformer in there. We're still making the conversion with a transformer, and there still are electrolytic capacitors like in the linear,
Okay.
but they're much smaller. And the key to that is the operating frequency. As I said, in the linear power supply operates at your line frequency, 60 hertz, which is a very low frequency. In the switcher, we use transistors to create a much higher frequency.
Okay.
The size of the capacitor and the transformer are inversely proportional to the operating frequency.
So by increasing the frequency, you can use much smaller
Yes.
components.
So just real simply, in a switcher, you take the AC mains in
Yeah.
and you immediately rectify it. You convert it to DC right off the bat.
Okay.
And then you apply that through switching transistors. You switch it on and off at a high frequency to create AC again, but at a much higher frequency, typically 50,
Okay.
60 kilohertz. So because of that much higher frequency, that means the transformer can be this size.
Yeah, if we switch over here. So this is the same component as
Yes.
it was on that.
This is the main
Okay.
transformer. These are the main output filter capacitors, much smaller, and it's because of the frequency.
Nice.
Now, there's a lot of other key differences, obviously, with the switching mode power supply. But as I say, we go from AC to DC,
To high frequency
convert that high frequency.
AC.
Then in the secondary section, we rectify it again, filter it, put voltage regulators to give the very precise DC outputs. And another nice advantage of the switching mode regulator design is that it allows taking feedback from the output. The power supply can actually monitor itself, see what kind of load's being applied,
Right.
and control the duty cycle of the transformer. So it essentially unloads itself if you're not using much current,
Right.
and then it immediately loads itself back up.
Okay.
So a lot of smarts are going on in there with all the transistors and
Yes.
integrated circuits.
Even though this is let's say it has smaller components, if you look at it, it's obviously incredibly more complex
Yes.
than what this is, right? Just in terms of, the ICs that you see, the circuit board, the PCB usage. all that
Lots
kind of
more
stuff.
going on.
Yeah. So is that one of those things that makes or breaks a good power supply? What kind of features go into making a quote, good power supply in your mind?
Well, a high quality power supply, and there is a big difference between a generic power supply that you might get with an inexpensive case. You pay $50 for a case and a power supply. You're not going to be getting a whole lot.
Right. And what's interesting about
It'll
that,
work,
not a lot of cases do that anymore.
No.
Right? And and I think that's because that mentality has kind of gone across the entire industry. And
Right.
most people say if you get a power supply with your case, it's probably garbage. You should start over with something
Yep.
else. And so a lot of people that even are making those really cheap cases aren't including the power supply because it's just wasted money.
Right.
At
You'll
that
just
point.
throw them away.
Yeah. Yeah.
But you can still buy inexpensive generic power supplies. In some cases, maybe you can get by with that. But if you've got a high-end gaming system or a server, something that you're looking for reliability, long-term, steady-state operation, you want a good, high-quality power supply.
Okay. So what do you want to look for in that?
Okay. The easiest thing is just a top name brand.
Right.
And there's a lot of them out there now, which is really a good thing for us.
Yeah.
But high quality components, a good design. When you look at the characteristics, you want tight voltage regulation. You want a low AC ripple and noise on the DC outputs. You want high efficiency. I'd look for a power supply that's got a nice high quality fan, dual ball bearings or
Oh, yeah, for
not a cheap sleeve
lifespan of
bearing.
that fan
Yeah.
type stuff. Okay. Yeah.
And the larger fans, as we said before, will give you a lot of air flow, good cooling with minimal noise.
Right.
Good cables are also a nice feature. You want a heavier gauge wire, gold-plated connectors. All these types of things go together to make up
So
a good enthusiast.
how much of that is marketing stuff versus actual useful
Most of
quality
it's
enhancement?
real stuff.
Okay.
I mean, you can always put a marketing spin on the different features,
Sure.
but bottom line, you still got to be able to do it right. It's got to be a good design, a good topology. It's got to be able to deliver the electrical performances that they claim.
Right.
And that's one of the big things that we do when we review a power supply is just check the manufacturer, see if they're being honest about their specifications.
Right.
And in this day and age, most of the enthusiast grade power supplies are.
Okay.
You really are getting what you pay for.
Now, that wasn't the case when we first started doing power supply
Definitely
testing, though.
not.
We would find a lot more interesting characters in the
Yep.
field, right? And so I think a
Yes.
lot of the review process is bringing these up. And we've had a bunch of new entrants, companies enter into the power supply market, right?
Yes.
So like, I'm going to miss some, but like Corsair was one of the ones who kind of came in and it was, I think that might have been like the first thing they did after memory. I don't know. I can't remember. It was one of the very early things they got into.
Memory and
XFX got into power supplies. You got EVGA now into power supplies. There's a lot of what I would consider just enthusiast brands
yes.
around other products that got into power supplies. There was a period, I remember just when running PC Perspective, when power supplies were like the hottest topics in terms of reviews. Everybody wanted to know about it because finally we were in the wattage race.
Yes.
Where we suddenly went from 400 watt power supplies up to, hey, we've got this 1200 watt, this 1400 watt, we've got this 1500 watt power supply. And there was a lot of questions about, do I need that? Are they actually rated at that? Will they run at that? And I think the review process, which we'll actually go over in a little bit about what exactly you do to test power supplies. We've got some photos and some things to show in that regard. But it's been very interesting to see that evolve over the last 10
and
years.
you remember, I mean, this goes back almost 10 years.
Yep.
There were very few really good power supplies. In the day, PC Power and Cooling was the brand to go to.
Yep, that was the first.
If you wanted a top-of-the-line 1200 watt.
I still have some of those. I
do too.
PC Power and Cooling Turbo Cools.
Yep.
I don't use it anymore because they're significantly louder than some of the new ones are now because we use a bunch of them. So.
Yep. But they were real expensive, but they were real good. They were solid.
Yep.
Like a rock. That was there. But now the market has expanded and there's a dozen or more different manufacturers making excellent power supplies.
And so why power supply reviews are still important then is as we have more competition, it creates more of a push for these manufacturers to try to find ways to cut costs.
Yes.
And thus lower the quality back again.
Yes.
And so more reviews are necessary to make sure that they're not doing that.
Yes, it's a very competitive market.
Yeah. Let's see, what else do we have on here? Power factor correction.
Oh, that's an interesting one.
So a lot of people may think that it's the same thing as just like efficiency, 80 plus gold, silver, platinum. Is that?
It's not.
It is not.
Power factor and efficiency are not the same thing. They are often confused, but they are two totally different things.
Okay.
Power factor is one of those kind of weird things that comes about from AC power. When you add in inductance and capacitance to an AC circuit, it affects what is called the power factor.
Okay.
In an ideal world and in DC circuits, and in an AC circuit that has active power factor correction or a power factor of unity or 1, current follows the voltage. Now, you know what a sine wave typically looks like. The current, as the voltage goes up, the current goes up. So they follow each other. They're in phase.
Okay.
Well, in an AC circuit, things get really weird.
All right.
And all of a sudden you find that the voltage is either lagging or it can be leading the voltage. So this creates all kinds of problems for the power industry, especially if it's for an industrial, a large plant that has big motors, transformers. It can really affect the power distribution company. A PC power supply isn't going to take down the power company, but it still can introduce harmonics, and it kind of dirties up by impressing back harmonics onto the power line. So most newer, good, enthusiast-grade power supplies all have what we call active power factor correction. There's actually different types. You can have passive, or you can have none at all. Go back 10 years, like this guy, this has got nothing. So it might have a power factor of 0.6.
And what does that mean?
0.7.
That's a ratio of how much it could lag behind or ahead?
That's like how much it's getting out of whack.
Okay.
And there's a lot of other things going on there too, but ideally you want to keep the current, at least what is the outlet is seeing, the current and the voltage perfectly in phase with no harmonics.
Okay.
So with passive power factor correction, a power supply manufacturer may add a few components to help it, and that might increase it from say 0.6 up to 0.7, In active, that'll take it all the way up to 1.
And what is that? Is that like IC circuit? That it's
Well, actually, I'll show you when we get into
Okay.
the power supply
Okay.
here in a minute. But yes, there's actually integrated circuits, and that's what they're designed to do. They look at what's going on, they make corrections. There's a lot of the components in there, transistors, chokes, that do that.
okay.
So again, just to reemphasize, power factor and efficiency are not the same thing. Having a high power factor makes a power supply more effective, but not more efficient.
So what is efficiency then? Efficiency is the rating of power input versus what it's actually giving to the
Exactly.
PC components, right?
And you have to look at watts. AC watts in, say if a power supply is using, it's truly drawing 1,000 watts, which is a lot.
Yeah.
It won't be able to output 1,000 watts because no power supplies are ever 100% efficiency. So what you get out is going to always be a little bit less than what goes in. Some of the newer power supplies are operating around 90% or more. The platinum certified units can be running 92, 93% efficient.
Okay. All right.
So for 1,000 watts going in, you're getting over 900 out. The rest of that is lost and it comes out as heat.
Gotcha.
That's why you have to have cooling fans. That's why all
Right.
electronic circuits generate heat.
Gotcha.
And
So
that's what
it's
kills them.
interesting. Yeah. So it's interesting, like when we do our GPU testing, recently we were doing a triple Titan SLI, which is the highest end single GPU graphics card you can get. And we were drawing almost 900 watts through this power supply, but at the wall, 900
Okay,
watts.
okay.
And so I think at that one we're using the Corsair power supply of some kind. So we were actually only feeding the system some percentage of that, probably in the 85 to 90% range.
Yeah.
would be
And you
my
can
guess.
look at that. You can look at the efficiency rating of the power supply and say, if it's a platinum unit, you can say,
Right.
okay, this is going to be doing 90%. And if you use one of your little, like a Seasonic Power Angel or some kind of an AC watt meter,
Yep.
you can see what the computer's pulling at the wall. Just do a quick conversion, okay, 90%. And you
Now that efficiency though is not linear completely,
no.
right? It varies based on the load. So it can
Oh,
be
yeah.
very efficient at some loads and less efficient at other loads, and
Yes.
it kind of varies
Like
based on that.
you know, in our reviews, when
Yeah.
we in the efficiency section, we'll always graph that.
Right.
And you see a typical bell-shaped curve. Most power supplies peak at around 50, 60%
Okay.
of their maximum operating load.
Are you seeing power supplies maybe lean further down towards higher utilization over the years, or is it still kind of staying towards the 50
For
to
the
60 range?
most part, that bell-shaped curve is typical.
Okay.
You start out really low, it ramps up pretty quickly, so above 10% load,
Right.
you should be hitting up into the 80%.
Okay.
And the 80 plus specification requires a power supply to deliver a specific efficiency between 20% and 100% load.
Okay.
Below 20%, they don't care what it does because you're not going to be operating down there too often. They're real concerned about where it's going to be at 50%, and that's the highest rating. They allow it to drop off at 20% and 100% just because that's the typical characteristic of
Yeah.
how they work.
So that's power factor correction, efficiency. What about single rail versus multi-rail?
Oh, that's a big one.
We get that question all the time.
Yeah.
Hey, I'm looking at power
And that's a good
supply.
question because there's a lot of confusion in the industry
Yeah.
about that. Now, if you go back 10 years, back to the day when we just had 300, 400 watt power supplies,
Yeah.
and they were only putting out 10 amps, 15 amps or so on the 12 volt rail, it was a non-issue. But as the output capacity increased over the years, the capacity of the 12 volt rail also increased. So it's
I mean, we're
not
up to like
uncommon.
what, 90 amps?
Oh, more than that.
Oh, really? Okay.
Well,
let's see.
the-
We always joke about on our podcast about that you could do arc welding with power supply.
Exactly.
So,
I think of that I think last year we did the EVGA, the Supernova, the
Yeah.
NEX 1500. And that's about the biggest commercial power supply that you're going to be able to buy
Yep.
right now for the U.S. market. And that is capable, I think in its overclocked mode,
Right.
it can put out 133 amps at 12 volts. And so I could weld with that, you know?
Yeah.
It may be
We may
hard
have
to
to do a
keep the
video
arc
of that.
stable, but
we
at
might
12
have to do a
volts.
video
but-
of that. We'll have to see.
well.
Still got that power supply?
No.
If not, we'll have another one.
Yes.
We'll have another one.
But
I think they
anyway,
would donate
so
for that purpose.
the issue became as the output capacity grew, and especially the 12 volt capacity, now you might have 60, 80, 100 or more amps available at 12 volts.
Okay.
Well, some people in the industry got concerned about that as a safety hazard. That's a lot of power.
Mm-hmm.
And if things really go bad, if you have a direct short, something happens, that can create a pretty significant fireball and even have the potential of ejecting molten metal. I mean, we laugh about that.
Have we seen
but
that happen yet? Hasn't happened to you?
I had, in the 10 years I've been testing power supplies, I had one actually explode. Only one.
Okay, all right.
It definitely got my attention.
I bet.
It was a
Were you weren't peering real close at it, were you?
No, I was not. And,
Okay.
And since then, there have been many times I wear safety glasses now when
Sure. Okay.
especially the big ones, because I never test them with the cover off. It's still enclosed, but there's enough open area out of there that
Yeah. All right.
some stuff can come out of there. But I tell you, that'll get your attention.
So they were concerned about a safety issue then.
Yes.
So some people started developing the idea of a multi-rail.
Well, and the ATX design guide came up with the idea, okay, we're going to limit the available power on any particular output to 240 watts. So basically that was 20 amps on a 12 volt rail.
Okay.
So manufacturers started adopting that, and they started doing that. And instead of having one 80 amp 12 volt output, they might have four 20 amp. So now you have four 12 volt outputs separate. So for quite a while, manufacturers started doing that. And then users started having problems depending on how you connect the cables and to which particular components. You might actually be overloading one of the outputs,
Right.
underloading another one, and it would appear like the power supply either was bad or was malfunctioning.
Mm-hmm.
It was a big hassle for both the end users
So
and for the manufacturers.
we kind of saw that when we started getting into higher end graphics
Yes,
cards.
I'm sure you did.
And we would go to NVIDIA and AMD, and they'd have these tech days, and they would talk about these new power supplies, because
Yep.
that was the big push for higher wattage power supplies, was now you can have 2 or 3 graphics cards in the same system. And they were mentioning you need to make sure that you've got 2 6-pin connectors on here. You need to have one from one rail and one from the other in order to get the best powering, most effective or efficient or stable power into the
Yep.
graphics card.
Yep.
So then what changed? Why did they decide, or how could they decide
Well,
to go back to single and start doing both?
My understanding, it's a guideline. It's not a rule.
Okay.
It's just a suggestion.
Right. Okay.
Now,
Yeah.
for the most part, manufacturers take those suggestions very seriously, the guidelines. But in this case, like today, it's still, there's 2 camps. Some people still support the multi-rail, think that's the way to go. Other people are adamant, single rail, just eliminate all your problems,
Now-
and that's the only way to go.
How would you say, if you looked at like the enthusiast lineup today, is it a 50-50 split? Is it more weighted towards single?
It's kind of like the pendulum. In the beginning, it was single rail. Then it started to become multi-rail. Now I see it's swinging back to more and more single rail. And quite a few power supplies give you the option, either with a dip switch or a little switch on the back, to switch modes.
Right.
You can pick whichever one you want.
Does that cause any negative?
No, because most power supplies, what they're doing, there still is just one 12-volt output. You might have the power supply that's capable of generating 100 amps at 12 volts, and then they split that up into 4 or 5 different outputs just by using current limiters, little IC circuits.
So that happens. So they're basically, they have internally
Yes.
they have a 100 amp circuit, but then they split it up.
Yep.
So that the end user, in theory, only actually has access to
Right.
20 amps at a time.
Exactly.
Okay.
And just by switching a switch, you could either cut in or cut out those current limiters.
So do you have a preference today then? Or
Yeah, I prefer single
you
rail.
prefer single? Okay.
And I'm guessing you do
It
too.
makes things easier. I
Yes.
just, are there any benefits to having multi, or is it simply that you
don't
actually
s-
completely meet the spec?
It's a safety concern.
Okay.
And for me, if you have a power supply with inside a case or inside its own enclosure, inside another case, your PC enclosure, you're pretty safe.
Okay.
I'm not too concerned about, even if it does blow up or something goes bad, I'm not going to, burn the house down or
Right. That would be a plus.
create issues.
So let's take, you brought this unit here,
Yes.
kind of disassembled. We've taken the top off where it has the
Yes.
fan there. Now this is actually a power supply from
This is a Be Quiet
Be Quiet.
brand from Germany.
Okay.
We reviewed this about 2 months ago.
Okay.
It's an 850 watt, and it is based on the Seasonic X-Connect design,
Okay.
which you'll find an awful lot of the top tier manufacturers, whether it's Corsair or XFX, or
Yeah.
they're all using the Seasonic
So I mean,
platform.
it's
which
interesting.
isn't
We should point out that like a lot of people maybe don't understand that the power supply market works like that. It's much like the graphics card market. In reality, there's only 2 or 3 manufacturers that actually build the graphics cards. But a lot of these smaller vendors will place orders for specific designs.
Yes.
Like, give me it with these little tweaks, we'll put our branding on it, and then we sell it. But they're not actually the one manufacturing. And the same thing happens in power supplies.
Yes.
Right? So the primaries are, who do you think are like the biggest ones? Seasonic, FSP, are they still? Okay.
Yeah, the Fortron source.
Yeah, which is actually where
group.
this one is from.
Yes.
Yeah.
Enermax actually makes
Okay.
their own.
Okay.
Now they have different OEM plants that
Right.
build the power supplies, but as you said, there's only a half a dozen or so true manufacturers. Everybody else is just going to them, and a lot of times they will just buy an off-the-shelf product and just relabel it with their name.
Okay.
But on the other hand, some people go with a design and say, hey, this is what I want. Here's my design. I want you to build it for me.
Right.
And in that case, it is truly a
It's an in-house
power
design. They're
supply.
just not the manufacturer. They're just
Yep.
outsourcing the manufacturer, which is fine. Yeah,
Yes.
Yep. As long as it creates new product lines with different, ups and downs and positives and negatives. That's a good by us. So if we look inside this unit,
Yes.
what's kind of interesting in here that's worth pointing out?
Well, I can just kind of take you through all the various components and the
Okay.
different sections, stages. We can look at least get an overview of what's going on.
Okay.
Let's start. The main power cord comes in here in the front, and you've got your master on-off switch. So this section up in the front here is called the Transient Filter stage, and it's filtering the incoming AC power. It'll
Okay.
use a combination of ceramic and polyester capacitors. You can see the little blue and yellow
Yeah.
components down there on there. Some ferrite coils, MOVs, the main power switch. So that all takes care of the power as it comes in, and that's this,
So is that
this
an attempt to
section
kind
in
of
here.
clean noisy AC as it comes in?
It gives you, frequently it'll take care of surge protection.
Okay.
So, and then it's going to come over here, this underneath this heat sink, and in this power supply there's actually 2 full wave bridge rectifiers. So this is where the AC mains now get converted to DC.
Okay. The first time.
Yes.
right.
The big coil here, that's actually called a choke. It's a big inductor. You'll see several of those around here. Then
Now, I have a question here. There's
Yes.
this piece of plastic kind of attached to it with some epoxy right here. What's the purpose of that?
it's just acting as a protect. You'll see there's a number of these shields.
Yep.
Just when the case
Oh,
goes
okay.
on to make sure you don't have some kind of contact
Okay.
between components. The white looking compound is used to secure components, keep them from moving around and potentially breaking loose.
Gotcha.
So,
Okay. So we had the choke
Yep.
there you were talking.
yeah, and this is actually part of the active power factor correction circuitry, which is taking place in this area. There's a little circuit board here that's got the IC controller
Right.
It's probably hard,
Hard
to see that.
Yeah, there's a white pin
But
there that you can
the
see.
big
That's going
heat sink
through it.
here, this has got the main power transistors, diodes,
Yep, you can see those through the
for
plastic
the
there.
active power factor correction circuits.
Okay. All right.
Now we're going to come back under this heat sink. We've got let's see, I think there's 4 in this power supply, the actual switching transistors, which are MOSFETs, high efficiency
Yeah, I can't really see
Power.
them there, but yeah.
switching transistors. And there's another little controller board here with an IC that fires those transistors.
Okay.
So that's making the conversion. Now we're converting back to high frequency AC.
All right.
Then the big filter capacitors here, well, big is a relative term.
Right. Yeah, they're the biggest in the power supply
That's
now.
still on the
Yeah.
part of the primary section that starts filtering that high frequency
Okay.
power that's coming out. And then the big yellow transformer you can see here, that's the primary transformer. That's where the voltage gets stepped down from a high voltage AC to a low voltage AC.
Okay.
And then the big section in here is what we call the secondary stage. This is basically a big 12 volt section, which is a combination of, it's more ICs, more transistors that does the regulation. Makes good, clean 12 volt
Okay.
outputs. Some other parts in here, the circuit board over here on the side, that's handling the circuit monitoring. It takes care of things like over voltage protection, under voltage, over current, the safety features that are all built into the power supply.
Okay.
Now, a key feature of the Seasonic X-Connect power supplies is, as we said, this is a big 12 volt power supply essentially. There isn't a 3.3 and a 5 volt section on the main board. They're actually located now on the rear connector panel. So this was the big thing when Seasonic came out with the X-Connect about 3 years ago. It really was a great idea.
Right.
And a neat innovation because it eliminated a lot of the wiring, especially the 3.3 and 5 volts. Even a tiny bit of resistance at those voltages can have an effect on the operation. So moving them to the connector board eliminated some wiring. It reduced the component count a little bit, which makes it simpler,
Right.
more reliable. But the big thing was just getting rid of those voltage losses.
So we actually have that.
I brought this is the board.
Yeah, here we go. So this is essentially what this is on this power supply, but from a different
Yes.
unit, right?
And if you flip that over, you can see now this is our two, the 3.3 and the 5 volt regulator sections. This is what we call a DC to DC converter. This takes 12 volts DC and converts it to 3.3 or 5 volts,
Okay.
which is then delivered out.
Okay.
And most of the newer power supplies use these. They may be actually on the main printed circuit board. They're typically on a daughter card. And in this case, they're on the rear connector panel.
So these are the main 12 volt lines coming into the circuit board.
Yes.
12
you
volt
got
and
your
ground.
12 volt and ground, right.
And then, so it outputs the 12 volts through, and the 5 volt and 3 volt all through.
Yes.
After, and then
Yep.
the 5 and 3 go through there. Huh. Okay.
And also, I'll mention one other thing. In all power supplies, there's actually a separate little power supply built in, which is the 12 volt standby. A little transformer here and some components right in this area.
Okay.
And that has to be separate because, as you know, when you turn your PC off, the main power supply shuts off. But you still have to have that 12 volt standby, so when you push the power on button, the PC knows to fire up.
Okay. All right.
And it also will
Now,
power.
do motherboards use that as well? I know a lot of
Yes.
motherboards are using that for, you can charge your phones or your tablets while
Right.
the PC is off.
Well, they figured,
They're
well,
doing
I've
it.
already got it. Why not
Okay. All right.
use it for your phone? Or
Huh.
yeah, they're being creative.
Okay.
But so even though the power supply's off, that 12 volt section or the little 12 volt standby section's always on, unless you pull the plug or turn the main power switch off.
Right. So every power supply will be a little bit different, or most
Yes.
power supplies will be a little bit different than this, but that's kind of your run through of what the different sections are of a unit
Yes.
will be. So
There's a lot of commonality there, but you're right. Different manufacturers, different vendors will do things slightly different. There's different circuit designs, different topologies that are used. So,
okay. I have a couple other questions here we're going to get to.
Okay.
Before I do that, I want to mention for people who are watching on the live stream that we have 2 power supplies that we are going to give away. As I switch over here to our system, you'll see here's our post. This is where you learned about our event and how it was going on. And we have 2 power supplies we're going to give away. We have an EVGA Supernova 1000 G2 power supply. You can see an MSRP there of $200.
Nice.
And an EVGA NEX 750G Gold power supply that's $120. Now we're going to give both of those away to people who are on the live stream. And how do you do it? If you go to this post on our site, there will be as soon as I actually enable it, a form for you to fill out. And it's really simple. All it is going to ask you for your name and your email address, and those need to be accurate, otherwise I can't contact you to get your information. And there's a question that just asks, what did you learn today from watching the stream? You can only enter once. Don't worry, it'll make sure that happens. And just you don't have to fill it out now. We'll draw at the end of the stream 2 names, one for the 1000 watt, one for the 750 watt power supply. So make sure you go. Let me see if that form is up and ready. Yep, here you go, Ken. You can show that up here now. It's real simple. Name, email address, what did you learn today about power supplies? And we will pick the winners at the end of the stream.
All right, good luck.
Yeah, thank you, EVGA, for that. All right, so that's the inside. Let's talk something about the outside of a power supply.
All right.
Fully modular, partially modular. Do they make no power supplies that aren't modular at all? I guess they still do.
Yeah.
What's your take on that? The idea of having a fully modular power supply or something like this where the primary ATX is hardwired, but the rest of it is modular?
Personally, I like what we call a hybrid combination, where you have a few of the fixed cables, your 24-pin main ATX cable, maybe your 4-pin or 8-pin motherboard cable, and a pair of PCIe connectors.
Yeah.
You're always going to use those. So why run them through
Why
a
make
connector?
them fully modular? Yeah.
And then make everything else modular. In my opinion, that's the optimum combination.
Now, that's your optimum? Is there a electrical difference between having it hardwired versus having it modular?
Technically, yes.
Okay.
Anytime you insert a connector, make a junction, you insert the potential for problems.
Okay.
You have a little more resistance, which translates to voltage drop. Depending on the material in the connector, if it's not gold-plated, it can oxidize over time, which can create problems. So if you don't need a connector, in my opinion, don't put one. So like the 24-pin main ATX.
Right.
I don't need a connector for that.
Sure. Okay.
So that's my take. But when you're looking at cables, you want to make sure that they're going to be long enough.
That's the key for me.
reach.
As the cases have gotten, well, they haven't necessarily gotten bigger, but as cases have changed, a lot of people are now routing cables behind the motherboards.
Yes.
And that's been the biggest pain for us as we build systems here, is a lot of times, especially that 8-pin CPU
Yes.
cable, a lot of cases now, like from Corsair and Cooler Master and those guys, will ship with an extension in the box because...
Now you've got that extra connection.
So now it's just like having a modular power supply, right? So is that one of the things you look at when reviewing a power supply, is how long are the cables? How much
We do.
flexibility does that give you? Okay.
And also you want to make sure they're a high quality, heavy gauge wire, typically a 16 gauge wire. It's not a real chintzy like a 22 or something.
Right.
Gold plated connectors. And that's fairly common with the high end enthusiasts.
So you would recommend, you think it makes the most sense to have a hybrid?
That's my...
But if I have a fully modular, it's not necessarily, it's not like a bad thing.
No, it's not a showstopper.
Okay, all right. I understand the reasoning behind that. As somebody who, we build a lot of test systems here, the cleanliness of fully modular can be helpful sometimes. But you're right, you're always using at least ATX and at least a CPU, and then More than likely, one or two of the PCI Express.
Yes. And there's
connections
certainly
as well.
a number of power supplies, good power supplies still in the market that are
Well, like for example, I mean, we had this
fully.
SFX form factor. It is fully modular, right? But you're still going to have to, at the minimum, use this and this.
Yes, but,
Right.
and I will add,
Or
one of the
one of these.
reasons, especially Silverstone, they're real good about that because they offer different cables. So you're not
Okay.
locked into just one particular cable that comes with this.
For
if you
length
need
or
a longer
construction
one
type.
or a shorter one,
Yeah.
you can buy it. So
Okay,
in that
that's a
case,
plus.
having fully modular is a good thing.
So it could be possible then that a fully modular for like, we recently reviewed the Corsair 900D, which is an enormous beast of a case,
Yes.
where it would be nice to have the option to buy longer cables. Now, I don't
Yes.
think most manufacturers really offer that, do they?
No.
Which is, I mean, you would think, I think somebody like Corsair probably should if they don't, because they are both making the cases and making the power supplies. They should be able to, I think they maybe include the extenders with that case too. So interesting. What about fanless power supplies? Now I should point out, somebody in the comments asked if this was a fanless power supply. The answer is no. We just took the top off that had the fan on it. So this would sit on there like that. It's not a
Yes.
fanless power supply. It is a,
Not an 850 watt fanless.
right, that would be great, but
Actually, this power supply right here would probably operate up to a couple of hundred watts without a fan
okay.
and be fine.
So, and that's actually interesting. So the fans are controlled by logic on the power supplies for the most part.
Yes.
So if it's not necessary to have them on, for the majority of kind of the high-end brands, they don't spin the fans up unless they're necessary.
That's something we've seen in the last couple of years is with the larger fans, they move a lot of air, so you can start out at a very low speed. 600 RPM is virtually silent.
Right.
And for me, that's my preference.
Okay.
I would much rather have a power supply with a large fan that's spinning very slowly, virtually silent, but it's still moving a little bit of air,
Yeah.
keeping things going, than to be a totally fanless.
The part that was harder for me to grasp was sometimes turning on the system, and that's the first thing I look for is the fan spinning on the power supply.
That's
That's
true.
how I know if it's on. It doesn't spin up necessarily. Sometimes you get that little hitch or jerk, like oh no, I don't need it
Yeah.
right now, and
And that's a big watch out on some of the power supplies now, and quite a few of the Seasonic brands, they offer two different modes, what's called cooling mode. It'll start out with the fan running very slow, and then it'll ramp up in speed as the load increases, which is just what you want.
Right.
But it also, you can switch it over to run in silent mode. So for the first, like we said, maybe the first 20% of the load, the fan won't be spinning at all. So that can be misleading. It's a little disconcerting, especially for us when we're working with the open test beds and you turn it
Yeah.
on and you say, oh, my power supply's not working. Well,
So-
it is, and you just have to be aware of that.
So then what's your thought on the idea of completely silent fanless power supplies? I know we've reviewed several.
We have, in my opinion, they occupy a niche market. If you truly want one and you need one, there are good ones out there that are available. Go for it. The one caveat to that I would add, coming from an industrial background, there are certain specialized applications where you might have a computer in a very dirty, dusty environment that would kill a normal power supply by just sucking in all the junk.
Yeah.
In that case, a fanless power supply, which is basically enclosed and just covered with big heat sinks to dissipate the heat, in that case, it could make sense.
So it'd actually be longer life
Yeah.
with the fan in that
Yeah.
case. Okay. What kind of wattages do they go up to in fanless in your experience?
Typically 500 watts.
It's kind of the peak.
600, I think, is the highest I've seen. And the biggest contributing factor to that has been as efficiency keeps going up, the heat dissipation goes down.
So you can put more wattage
Exactly.
through and dissipate the same level of heat.
Exactly.
Okay.
Where
So
a-
it kind of makes them more expensive, though, right? As we go
It
into higher
does.
efficiency, the cost of the components, therefore the cost of the power supply,
Exactly.
goes up pretty dramatically.
Yes.
We've seen that with a lot of the 80 plus platinum
Yes.
units are significantly more expensive than
They
gold
are.
or.
But there's a
anything like
lot
that.
more going on. They're
Yeah.
using the higher quality components, more expensive components to
Right.
get that higher efficiency.
To me, it only makes sense to look at a silent, fanless power supply if you are trying to build like a low-power home theater PC, something that's going to be not going to have a whole lot of components in it, right? The idea of looking for a fanless power supply in a system that you're going to put a discrete graphics card into doesn't make a whole lot of sense, because you have to have a fan for that discrete card.
Yes.
Even if you're water cooling it, you have to have fans on those radiators.
Yes.
So in most of my experience, the noise from the power supplies, for good power supplies now, is less than what you have to worry about with your processor fan, with your GPU fan, and unless you're building a home theater PC that's using integrated graphics and you're going to try to use a super quiet or fanless CPU cooler, it's not a necessary feature to go with a
But even that, a big caution, and a lot of people go that route when they're building a home theater PC.
Yeah.
No fans, passive coolers, low-end CPU, and then they'll go with a fanless power supply. So in the end, they've got this enclosure with no airflow at all. Because the enclosure that's part of the ATX design guide, the case expects there to be a certain amount of airflow through the power supply.
Gotcha.
And in a super quiet computer that doesn't have any other fans, it relies on that air through the power supply. And if you put a fanless power supply
So if you
in
take
there,
away everything,
now you got nothing other than just a hot box that's going to get hotter and hotter, and it may survive for a few weeks, months, but
all right, something to consider.
yes.
What about when you're trying to figure out what size power supply? That's probably the most popular question we get is, here's what I'm thinking about buying. What size power supply do I actually need? What's your kind of rule of thumb?
My rule of thumb is 60%. That's what I go by.
60%. You want your power supplies primary max wattage.
Say this is a 1,000-watt power supply.
Yep.
My load should, when I'm running the computer, maxed out normal load should be 600 watts.
That seems pretty that's a big gap, especially if we get into the
That's
1,000-watt
lower
power
than
supply.
most people. Typically, you'll see 70, 80%. Again, that's my personal choice.
Right.
But what that does, if you're...
If you're running, the problem with that is if you're running triple Titans and SLI,
Good luck with that.
I don't think they make a power supply that will get you to that 60%
Well,
rating,
maybe
so.
the 1,500-watt EVGA.
Yeah, that's true.
Maybe.
Yeah.
But yeah.
So what's your kind of thought process behind that?
Where I'm coming from is a couple of things. If you take a power supply and you operate it in that 50 to 60% of its max capacity range, that's going to make it the most efficient. That's typically where a power supply is the most efficient. It's going to keep the AC ripple and noise well under control, because that goes up as the load increases.
Okay, all right.
Voltage regulation is going to be tight. It's also going to allow the cooling fan to stay at a nice, slow, medium speed without getting real noisy.
Yeah.
The only downside is you're going to pay a little more.
Okay.
But I would always err on the side of being a little too big rather than too small.
Yeah, okay. Yeah, I agree with that, and we definitely recommend that. So, you see a lot of the power supply minimum requirements with like when you're buying a graphics card.
But the other piece of that question is, well, then how do I figure out what my load is?
Right.
And if you're doing a new build, well, you're going to have to look at your components, the motherboard, the hard drives, the memory, the CPU, video cards, all of that, and estimate or measure, if you can, go to the manufacturer's websites and get the numbers and then add it all up, and you'll come up with a load.
There are some websites that purport to
help you do that, right.
Wattage calculations where you kind of tell it what components you want to build, and it will give you an answer. I can't vouch for the accuracy of all those, so I think it makes the most sense to, if you're buying like a 770 graphics card, you go to NVIDIA, what's the max TDP on that? Okay, write that down. What's your processor max TDP, and what's its max wattage draw, and all that kind of stuff. And calculate it as close as you can that way.
And again, if you have an existing computer and you want to buy a new or replacement power supply, take one of your little power monitoring, put that on the computer, see what you're actually drawing. If you're gaming, what's your max load? Divide it by whatever the efficiency is of the power supply you're wanting to buy, whether it's 80%, 90%, and that'll give you a very accurate number.
Okay. Any other thoughts on which wattages to pick? I mean, so So you're saying 1,000-watt power supply if you think you're using under a kind of like a max load of 600 watts or so. That's while you're gaming, while you're doing the most kind of intense thing.
Yeah. Now you might, if you're gaming, you might go over that.
Okay.
You know, and you've got plenty of headroom.
Right.
But your normal average main load,
Okay.
50%, 60%.
Okay. Okay. That gives us a little better idea. Let's talk about now how we test power supplies
Okay.
here. How you test power supplies in that office while you're worried about fireballs. How exactly we go about doing that.
Well, we've come a long way since we've been working together for, 10 years or so.
Yeah.
To go way back when, I guess it was about 12 years ago that I started testing power supplies.
Yep.
And at the time, I built just a little homemade load tester, just a bunch of precision wire wound resistors and some switches. And back then, most of the review sites, you get a power supply in and you say, oh, this looks pretty. Maybe you hook it up to a computer.
You would hook it up to a system,
works great.
and you'll boot it, and
good to go.
I can run my components, so it worked. Yeah.
So you didn't know anything because you weren't testing it under repeatable, controlled load.
Right.
Controlled conditions. So the whole industry has come a long way. There's a lot of good hardware review sites now that are doing very good, thorough reviews of power supplies, and we're one of them.
Yep.
So instead of bringing everything with me, which I couldn't very well
complex,
do,
so yeah.
This is the PC Perspective Power Supply Test Lab. And what you see here in the picture, this is an overview. Actually, we have the Dark Power Pro in its test condition here.
Okay.
Let's see, I guess they can't see.
If we switch to there.
I'll just point out some of the main components here. This is our power supply under test. Now, normally, I have some passive duct work or a plexiglass enclosure that the power supply's in to maintain the temperature. I took that off so I could take the picture and you could see things.
Gotcha.
The X-Tech power analyzer over here, this is monitoring all of the AC power going into the power supply.
All right.
I've got a fluke temperature. We've got thermocouples on the inlet and outlet. We've got a bank of 6 DC programmable loads in the back here, 3.3, 5 volt, and then 4 12 volt sections.
Right.
I've also got some, and we'll have a picture of that in a minute, some additional 12 volt loads if needed, so I can load
Test
up
the bigger power supply.
to 6, to go up to 1,500 watts. A bank of just precision resistors for the -12 and the +5 volt standby loads. Sound pressure level meter, 3 feet away from the power supply. Digital oscilloscope running on a silent little low-end Dell laptop.
Gotcha.
A very accurate benchtop DC voltmeter. Those are the main components.
Okay.
I don't think I missed anything.
Yeah.
So let's take a closer
Calculator?
look.
What about the calculator?
Well, this is the data. I've got a full manual. That's for the manual calculations, actually doing efficiency.
Oh, okay.
Because I can get AC watts off of here. I can get my DC watts by adding up all the loads, and then dividing the two, I can get exactly what.
Okay. All right. All right.
So what's our next picture?
There we go. How about this? This is a close-up of the actual power supply.
Okay, this shows
tested.
the thermocouples and the temperature, the differential temperature of the air in versus the air coming out.
Is that the 18.3 versus the 19.4
Yes.
there? Okay.
Yep.
Okay.
So that's our differential temperature. But to say, again, normally we would have the passive air ducts or the hot box enclosure
Right.
for the true testing.
Okay. Next.
This is the sound pressure level meter. And when I do this, my lab's actually in the basement of my house. and the meter will actually go down to 25 dBA, which is really quiet.
I don't get that here.
Oh, you won't.
Here we get 29 maybe
Yeah, on
at
a
the
good
lowest.
day.
Yeah, at a good day. When
Well, even
everybody
my-
else has gone home,
My house,
we turn off the air conditioning.
with nobody home, I can't test if,
Right.
people are home and running around, so I actually turn off the AC, I unplug the refrigerator to get down, and I can get my background down to 26, 27.
Huh.
And to me, that's just dead silent.
Yeah, at 29 here, I think it's silent too.
Yeah,
So, but
it's-
yeah.
So anyway, that's for our sound. The digital oscilloscope, that's how we measure the AC ripple and noise on the DC outputs. There's a close-up of the loads for the -12 and the +5.
Okay.
What's next? Oh, this is one of the auxiliary. If I need more load than the 6 programmable loads are very accurate. I can just plug in to 3 decimal places, like how many
How much
amps,
watt
how
you
many
want it to
watts,
draw.
and typically I use watts
Okay.
because it makes it easier for my calculations.
Right.
But if I go beyond that, I have 2 of these that I made that I can hook up to a 12-pin EPS or an 8-pin EPS connector and a pair of PCIe connectors
Okay.
to pull another 436 watts each.
Nice.
In-
And this is something you just built. This
Yes.
is not something you
no.
bought, right?
No,
Okay.
no, that's homemade. But it has 2 modes. Low power, it's 218 watts per channel, and the fans don't kick on. In full power, if I've got all 6 digital load testers running and I need these, a couple more fans isn't going to matter.
Yeah. All right. So with these and the digital ones,
Yeah.
what do you think your max draw is?
Theoretically, I can take a load up to close to 2,000 watts.
Okay. We don't have any of those
Luckily, I've
power
never had
supplies
to
yet.
do that.
Yeah.
This is a close-up of the X-Tech power analyzer. You can configure it for different displays, but I typically look at the AC voltage coming in, and I do a series of tests at 115 volts, and then again at 240.
Okay. All right.
And that lets you compare the efficiency, because the efficiency changes fairly dramatically. Actually, it's very noticeably. Maybe 2 percentage points as the voltage goes up. So
Is
does
more
the
efficient at
efficiency.
240
Yes.
than it is at
Yes.
Okay. All right.
Yep. So anyway, so we see what the voltage is. This is our power factor. This is how many amps I'm pulling on the AC line, and this is the watts. That's the power supply is pulling 300
Through
watts.
here, through the actual output
Yes.
load. Okay.
Yep.
All right. And here are the digital.
This is the bank of 6 DC programmable loads. I've got, this one's configured just for 3.3, this one's for the 5 volt, and then these 4 are for the 12 volts.
Okay.
I've got them hooked up so that one is running off the 24-pin main ATX connector. It's got a couple of 4-pin Molexes, a couple of the SATA connectors to feed the 3.3. I try to use as many cables as possible when testing, just to eliminate. This one's dedicated to the 12-volt ATX EPS.
Yep.
I try to use an 8-pin, and then these 2 use 2 PCIs each.
Okay. Now, if you have single rail versus multi-rail system, how does that change how you have to connect these?
Normally it doesn't, because I have so many loads. I typically can share
Take
the
up as many
load
cables
enough
as it is anyway.
and spread it out so that I don't have a problem. If I have the option, I normally test in single rail mode.
Okay.
Just to make sure that I'm not introducing error.
Gotcha. And I don't know if I think that's the last one, actually, yeah. So that is it. We'll go back to this first one here.
Okay.
I mean, it's still impressive to me. I mean, we've been working with this kind of setup, and I know we've had to add to it. You know, especially with we got into the 1,200 watt power supplies.
Yep.
14 and 1,500 watt power supplies. So that's pretty impressive stuff. So that's kind of a summary of common questions we get, common concerns we have. Switch back here, and how we go about testing power supplies. What do you think about the power supply industry as it is now, how it's evolving? Do you see a lot of change coming in the future with it? Or are we at like a stable point where now it's just about how much more efficient can they get? Do we need to watch out for them pulling back on high quality components, that kind of thing?
I think we've kind of reached a plateau. There's been a lot of changes over the last 5 or 6 years as new players, have gotten into the market, especially manufacturers that make motherboards, video cards. All of a sudden, okay, we want to sell power supplies now too. It's a very lucrative market, so why not?
Right.
So in that sense, I believe the market is fairly mature. There's a lot of good high-end players. You got a lot of options.
What if you could tell these manufacturers to fix one thing or change some things? Is there anything that stands out to you as, hey, you need to do this better, or we can do better than this? Is it, like, to me, it would be, let's lower the price of platinum efficiency units.
That's a fair request, and yet at the same time, I understand the reality of it. Hey, it costs money to build a good
Right.
high-end power supply.
Right.
And they got to make money at it to stay in business. So
Yep. Yeah.
I'm okay with that. This particular platform here, the Seasonic X Connect, is just, it's hard to imagine for me getting much better than this. We're up over 90% efficiency. It operates most of the time very quiet, if not just dead silent. Extremely tight voltage regulation, like maybe plus or minus 2% instead of the recommended 5.
Right.
AC ripple, it's virtually not measurable. You got clean DC outputs, good reliability, excellent fan, nice cabling. It's a very mature product.
I'm sure. What about like the software implementations that Corsair has done?
That's
EVGA
interesting.
Has done? That's kind of a cool innovation.
Yeah,
Right?
it definitely. The people are coming along and trying new things to get your attention. To hey, buy my power supply.
Right.
Corsair offered a power supply with the control and monitoring software. EVGA with the Supernova.
Yep.
The NEX 1500. Very cool. If you got some geek.
They were.
And you like that.
It was cool to open up the software and see
Yeah.
how much power you're using
Exactly.
Through each rail. It's kind of interesting for us to even think about it. How do we test other components now? How accurately can we measure through software power of the graphics card or power from the processor without having to get into external equipment and USB, WhatsApp-based power monitoring and that kind of stuff? It could be very interesting.
We looked at a power supply last month, the high power Astra, the 700 watt Platinum, which had a built-in LED power display on the back of it. Yeah, which unfortunately it's on the back side of the power supply, which is going to be on the back side of your case, so you
we talked about that. That
can't
was
see it, but
turn that case around.
in the past, Thermaltake for years made one what they called the watt monitor, which is a little 5 1/4 inch bay panel that you mounted up, and it'd give you a display of what the power supply load was.
Right.
So they're looking for different ways to make their power supplies unique, but
Okay. All right. Before we get our final thoughts, I'm going to mention one more time. If you go to PCPro.com and you look for, let me bring it back up here, this post. You'll see this post. It's on the front page. It's actually still in our carousel too. If you go here, it's talking about this live stream that we are just finishing up. It will tell you about how you can win EVGA 1000 watt or 750 watt power supply. All you have to do is fill out this form. I'm going to give you guys like another 30 seconds or so to fill out this form. Name, email address, and what did you learn about power supplies today. In the meantime, I'm going to ask a couple of questions that we actually got on that thread.
okay.
And then we'll finish it up with picking our winners and getting any last thoughts. Razor 512 wanted to know about, we talked about this earlier, if he had a cheap power supply that he had from years ago for buying a case that came with the system, he said his died. He manually replaced the capacitors from cheap 85C caps to higher end 125C 10,000 hour ones.
Okay.
And he says now it's been up and running for a year since.
Okay.
Is that a realistic option? If you have a cheap power supply, or maybe you want this case and it happens to come with a cheap power supply, is manually replacing those things a good option, a bad idea?
Well, it's certainly an option. To me, it sounds like a lot of work. You're still going to wind up with a cheap power supply, but it's certainly doable. I don't discourage anybody if they want to, but again,
So you just don't think it's
it's-
worth the effort necessarily, because
for most
you can only
users, I would say not.
the issue
but-
is you can only replace that component.
Right.
You know, there's tons of other components on power supplies that
There
you cannot
are.
replace.
And yet, the electrolytic capacitors are one of the most sensitive to temperature. The higher the temperature, they break down and degrade over time to the point where they quit working.
Okay. One question here. This was from AudioFile. We talked about what is the difference between a 6-pin connector and an 8-pin connector in terms of the PCI Express cables that come off of power supplies, in particular for graphics card companies. Because some of those graphics card companies provide 6-pin to 8-pin adapters,
Yes.
is there actually any difference in
That's a
what
good
these
question.
cables are
because
providing?
As you and I talked earlier,
Yeah.
the 8-pin connector is technically rated, I believe, at 150 watts.
Yep.
And the 6-pin is only
75.
75. But, and so you would think the 6-pin connector's got 3 wires, 3 plus, 3
Right.
minus. So the 8-pin's going to have 4. Well, it doesn't.
The
It
extra
still
2
only
are
has 3
ground.
12-volt wires. The 2 extra pins are just ground. So technically, it is rated at a much higher capacity,
Yep.
so it makes a difference.
Is it something that's
reality-
maybe in, like, it's just a specification difference? So if you're running higher wattage, thus higher amperage through it, you've got to make sure you have additional grounds on it
I'm
for safety
not sure
or
what
something?
they're thinking on that is.
Okay. But there may not be a difference. I think he kind of answered his own question, the fact that if EVGA or whoever includes an adapter that lets you convert a 6-pin into an 8-pin,
Yeah,
and you can
most of the
still
time
work your
you're going
graphics card, then
to get by with that.
yeah, I think so. He also asked, is there anything different you would look for in a power supply for a gaming machine versus a home server, a system that has maybe 15 hard drives in it? Would you maybe choose single rail versus multi-rail for each of those applications or anything?
No, I wouldn't choose single or multi-rail. In both cases, I would look for a high-end, high-quality, enthusiast-grade power supply.
The last thing you want to do is have 15 hard drives get fried in your
Yeah.
home NAS because
Yep.
you went with a lower-end power supply.
Yeah, the gaming machine, it's the graphic adapters that are going to be pulling most of the power. With the server, it's the hard drives, but it's still 12 volts, and that's what the power supply is delivering.
Right. Okay. I gave you guys all of your time. This is now where we use the mythical beast of a website that is random.org. And let's pick our 2 winners. The first winner will get the 1,000-watt EVGA power supply. And the second winner will get the 750-watt EVGA
All
power
right.
supply. Many thanks to them for helping us out with this and getting some prizes there. So the winner of the 1,000-watt is Fishbait. I hope that's just a username. And the winner of the 75-watt is an anonymous user. That I guess I'll click this and at least Justin Rita. Justin Rita. So I will get in touch with both of you for information about your shipping address and information and all that deal that I will then pass on to EVGA, who will send over those power supplies to you. So do you have any kind of closing thoughts, ideas, or what people should look for or what they can look forward to seeing in the world of power supplies?
Well, you can look forward to seeing more good reviews on PC Perspective, but
That is a very good point. That's a very
I
good
think
point.
we've covered the highlights.
All right. Well, thank you very much for coming
Thanks
out.
for having
I know
me
it's, over. It's a decent sized drive to this side of the river for you, and I hope that everybody that watched it found it very informative. If you guys have questions, as he mentioned, go to PCPer.com. Go to our cases and cooling and power supplies section. We have a ton of power supply reviews there, and he tends to get them out there fairly regularly as well. Chances are, if you're looking at a power supply, he's looked at one, if that in that family, if not that specific one. So again, if you guys have any more questions, feel free to email me or email him, and we will help you out. Otherwise, thanks guys for watching this live stream, and make sure you check out PCPer.com/live for other upcoming live events. We have our podcast tonight. We do that every week, and some other things coming up at QuakeCon as well. Thanks guys.
See you guys.